Okay, so hello everyone, welcome to my channel. I will quickly check if we are live or not, and I'll also check the audio. I cannot see the broadcast. Okay, yeah. So we have this here. I will just check if we have the audio thing coming up. Right, so
I cannot see the broadcast.
perfect. I guess we will have some screen right now.
Okay, yeah. So we have this here. I will just check if we have the audio thing coming up. Right, so I cannot see the broadcast.
Cool, yeah.
Perfect. I guess we will have some screen right now.
Okay. So without any further ado, let's start this. So basically, those who are new to this channel, I'll be solving today's Leetcode problem live, and I haven't seen this problem before, and this is my fresh attempt to this. And yeah, that's it. Basically, just read the problem, make a algorithm approach, and then move to coding, and then we can just code it up. So guys, there is no constraint on which language we program the logic with. The main thing is basically you should be aware of data structures, and you are aware of the language specific things, like in Python things are different, C++ things are different, but the core thing is building the logic which finally works as an algorithm. Okay, now let's read the problem. So the step one is reading the problem and understanding what exactly is required. Okay, so this is the problem. Construct smallest number from di string. Okay, so constructing smallest number from di string. What is a di string? We have to construct a smallest number. Okay, let's see what the question says. You're given a zero index string pattern. The string is pattern, it is a zero indexed, of length n consisting of the characters I, meaning increasing, and d means decreasing. Okay, so I means increasing and d means decreasing, and there is a string which I'll call pattern. Okay, it consists of i's and d's. Okay, this means increasing, this means decreasing. Cool. A zero index string num of length n plus 1 is created using the following conditions. Now a zero index string num is created from this string following these constraints. Num consists of letter. Okay, so it has num consists of digits 1 to 9. Okay, where each digit is used at most once. Okay, each digit is used at most once. So basically num has unique characters, right? The pattern, if pattern I equals to I, then okay, so this is the constraint. Basically, if for the ith index in num, right, right, so it's like this. So we have, let's say we have pattern over here, 2 3 4 5. Yeah, this is 4, this will be 5. So the relationship between these two will be defined based on this one, right? And relationship between these two will be defined from this particular pattern I value, and relationship between these two will be defined from this particular value, and relationship from the between these two will be defined from this value. Okay, and then there is no further relation because of the end of the string. Okay, so to return the lexicographically smallest possible string num that meets the conditions. So basically we have to create a lexicographically smallest possible string. That means the basically it means that the lexicographically smallest means like when you put that string in dictionary, it would be at the top. So out of all the combinations which is possible based on the given pattern for the particular num, sorry, for the particular num, you have to return the one which is lexicographically smallest. So what this means ideally is that we can just create a number. Basically all of these will all together be a number, so we can just create a number that is smallest in the value, right? Okay, so now let's take an example to take a look at the test cases which were given to us. You see, this is the first case, which is, let me just draw it quickly. I'll just quickly discuss it, then it can build our logic. So this is I. Wow, I was lucky it fit. It got fitted here. Okay, so here we have this. So here we have this, right? So for this, they have created. Yeah. So for this, they have created this one. 1, 2, 3, 5, 4, 9, 8, 7, 6. Cool. So you see here, it's increasing over here. If it's increasing, it's better to choose the smallest guy here, which is 1, and then we have to put 2 to make it smallest. Why 2? Because if you put 3 over here, it would be anyway greater than let's say if I had put a 3 over here, so no matter what combinations I keep over here, it is always going to be lesser than 1 2, which we have at the head start. So 2 is an ideal choice for this. Let me change the color. 2 is an ideal choice for this. Then we have this. Here you see it's increasing. If it was decreasing, okay, so if it was decreasing, we cannot keep 3 over here for obvious reasons, and we cannot even keep 1 over there. So if it was decreasing, it means that we cannot even keep 2 over here. Okay, because if we keep 2 over here, then it absolutely makes no sense, right? Because if so right now it's increasing only, so it's straightforward. We keep 3 over here, which is like following the order of smallest one. Then we have increasing over here, so ideally you should keep 4 over here, and it was just fine. But like I was discussing earlier, what if here is a D? So if I kept 4 over here, so I need a number which is smaller than 4, right? So which won't be possible because all the numbers which are less than 4 are typically used up by this time, right? And we all know that the num is unique. We can use these things at most once, right? Which brings to an obvious constraint, which is, yeah, the pattern length should be between 1 to 8, and then this num string can have maximum of like 9, yeah, 9 characters, right? Now let's come to this particular D over here, and right now, so we cannot keep 4 over here because of this D, and we have more D's over there, right? Right, makes sense. Okay, right. So we kept obviously 5 over here, and then we have kept 4 to make it decreasing, right? So basically to make it decreasing, we have like written 4 over there. So this relationship is increasing between 3 and 5, and this is decreasing, right? Now if I have used a decreasing number over here, now I can go ahead, and the best choice could be again 6 over here. But you see here, for the further things, we cannot have any number which is less than 6, right? So in that regard, we had to make sure that we use this. right? So they come up with 9, and 9 was a good choice because this is an increasing one. So it was not 6, it was not 7, it was not 8, because of these extra d's we have got, right? And the problem which I explained to you earlier, that was that if we use immediately increasing number and there is a d after that, it makes no sense, because we won't be able to get a smallest number to make a successful decreasing order over there, right? So it's fine now. 9 was there, then we can just go decreasing, decreasing, decreasing. So by analyzing this test case, what I am actually getting is, okay, so what I'm actually getting is this logic. Start with smallest digit as, sorry, start with as smallest digit as possible. Now this term is used as possible. So we need to make sure, we need to adjust how i's and d's are going to be incorporated, right? So let me show you how we can do this. So right, so let me just understand the pattern. If it's I, so we can go increasingly, and then if there d's, we can go down, right? Now for going down, and let's say if there are a lot of i's, so it's better to start with the smallest number and go progressively. Make sense? And now let's say we are getting these over there, so obviously we cannot, let's say this was 1, this was 2, this was 3, so this I is incorporating for this one, this is for this one. Now there's one more I, so we can go for 4, but there's a D over here, so we need to adjust this. So how we can adjust this? Because of all these numbers are used up, right? So what they have done is basically, instead of taking 4, they jumped to 5, right? And then for D they need to come down, and this particular spot should be open for a number. This spot could be anywhere below this, but to make it a lexicographically smallest one, you have to keep a spot right below this. So yeah, I see one D over here, so I'll just quickly come down. If there were two D's, I would need two spots, right? I'm talking about immediate D's, right? So I would need two spots. Let me just make it a clear logic. I think I have cracked the code um, of how to solve this problem. Let me show you. So here we have this 1, 2, 3, 4, 5, and 6. Now consider these as open spots, right? Okay, it's too much getting. Alright, alright. And now let us consider a simplest pattern which I wrote just above. Cool. So this is the pattern which I have written. So like what I'm saying, we will start with, since we are making a lexicographically smallest one, we will start with i's. So we will start with 1. So it's an increasing thing. So I'll just quickly start going increasingly. So the norm which we are forming here is 1. Then we have 2. And then we get to 3. So this is one I used up. This is another I used up. I have one more I. So now I can go to 4, which makes absolute sense now. But as soon as I see a DU at the next spot, I need to come down, right? But there is no empty spot available for me, right? So due to this particular reason, what I have to do is basically this. I cannot take this one. For incorporating 1D, I need to go one step above, leaving this particular bar empty, so that for the next D I can come down, right? So this is again an I and this is a D, and now it makes even, right? Now we can just keep going ahead, right? But you see here, now we have one more D over here. So for D's we need one more empty spot over there, but that is not possible because all of these are occupied, right? So in that case, this logic comes up. Count the number of continuous D's we can spot it beyond this point, right? So listen to me. This is the number of continuous D, like contiguous D's, which we spot after this. What does that mean? That we need to spot this in a contiguous manner. Okay. So if there are 3 D's, so we have to make a jump at this particular step to by by leaving up 3 empty spots for the numbers to get adjusted. Like the 3 D's we can get down. So it would be like this. Just a second. Right. So it would be ideally like this. So I have to make a jump, which is at this spot. It would be an I, and this I has been incorporated. This I has been incorporated. This I has been incorporated. And now there are 3 D's, so we need to come down 3 times. So for the next one, we will take this, and then this, and then this. So this is the logic, right? Now we see an I, so the next empty spot we see at this particular place. So we'll just go up here. So the number which I'll be getting is, so 1, 2, 3, this is 7, this is 6, this is 5, this is 4, and this is 8. So the number which I'll get is 1, 2, 3, 7, 6, 5, 4, 8. So this is the logic, I guess, and it is correct in my opinion. Now let's write it in a more layman terms, basically more what should I say? This should be in a more broken down form. So the first thing first. So the string name is pattern. Inside this pattern string, we need to go like this. Okay, let me think about that. So what I spot is basically, let's say if this is a string, right? So we need to capture these things, okay, and these things. Basically, I'm concerned about about strings which have which have contiguous T's and an I attached to them, because this increase will help us make a big jump, and then we can get down and down and down, right? So here we could not find that. It will be just this one, and this is an alone guy, so it will be just. And now I'll maintain a variable called not count. It will be like pointer, not pointer. It will make you guys confused. This will be simply progress. Progress means we are starting from 0. We can go till 9, right? Progress means like the we are using the characters in a continuous form, so we will start with 0. The moment we see a D, we keep it so basically the moment we see a D string, I call it a D what should I call it? I should call these type of strings which can have I or cannot have I in front of them. So I'll call these strings as D strings, right? So for a D string, If we get a D string, then we have a, if it has I in front of the string, basically IDD type. If it has I, then we can uh, literally do this. Let's say the length, this is the length of D string, right? So yeah, so I'll call this D count. So D count is, let's say, some number like n, and I'll call this progress P, right? So we need to jump n spots, right? So this particular number will be filled up with P plus n ideally. And now since P has already been used up, so we'll ideally, this 0 has already been used up because we have to start from 1 and go till 9, right? So we will go with we will ideally go with P plus 1 plus n, because P is itself used up. Now this is like the spot we book for, we leave for the first one, and then we have this for second, this is for third, and P plus 1 plus n means somewhere here. So I'm making an I jump for this, and these are D's for D's. So yeah, it makes sense to me, right? So if it has I, do this. If it doesn't have I, then we have just D count. If it doesn't has D, we have just D count, and then we can do this, simply this, basically we can start with. So we are at this spot, this is P, which is already used up. Okay, and then it has just D's and D's and D's. Probably, yeah, this will be possible only if we consider the case at the beginning, right? So we need to quickly jump to this point. This will be, just let me think about it. So we are at 0. This is the fixed case because there will be 0 only, right? Right, it will be 0 here. So let's say there are 3 spots. We can keep simply 3, 2, 1, right? So this is like P plus n only. So start from P plus n, go P plus n minus 1, P plus n minus 2, right? Like this. This is fine. Here we start with this guy and then we go decreasingly. P plus 1 plus n minus 1 minus 2 minus 3 all the way up to n. Right. Cool. So I think I have the logic. I have to capture these strings. String. Just update the progress with P plus 1. And P plus 1 will be here. You see that? The logic is simplified now. We can jump to the coding section. So first thing first, how we will do it. So this is the algorithm. Now in code, if we have a string called pattern, or whatever it is, what should we do? If we spot an I, then check next character. If D, if I, if I, then do this logic. P plus 1 wala logic, basically this logic. If there is a D, this case, in that case, you need to go ahead, keep going ahead until you spot D's, and then you have to process this, right? This is fairly simple logic. This is pattern string, right? So this is basically a for loop where at each step we check next character, right? If it's a D, okay, let me just go back. So we started with if it was an I, if it was a D, so if it's a D at the beginning, you'll notice it for sure. So then we need to just process this stuff. We process the subsequent D's, and then we do that. So this is a D string without I. This case which we discussed over here, if it has I, if it doesn't have I, then basically this is the entire logic, and I think I'm good to go with the code. And let me just take you to the, okay, so we had good discussion here. Okay, give me a minute to take me to the coding screen. Okay, fine, just give me a second. Okay guys, so let me just open my Leetcode. Just give me a second. Yeah. Vehicle called right. Okay, I think I'm good now. Okay, um let me turn on D&D. How can I do that? I guess it's already turned on because okay, so right, we have this code editor in front of us, right? So I code in C++ because it is very much good for these, and I have been doing it since quite long, but it doesn't matter if because we have already framed out the logic over here. I'll be simply coding this approach. It's not that straightforward to code it, but yeah, I think I can do it because I have done it previously. Like this kind of flows quite some number of times. Okay, so we have the string. So I need some numbers for this pattern dot size. Let's yeah keep it pattern only. I hope this size works this way. Maybe this is the correct syntax. I don't know. Uh, let's keep the string num, which is this, and then we need some things. the progress integer, which is initially 0, right? And then we need to get into the pattern string, right? So for that we need to use I-based indexing, right? For integer I plus plus, what we need to do here is we need to execute that logic. Yeah, so how can we go ahead with that? Right. So if you are processing it, it will be the current character would be, in most cases it will be this one only, I only, except for the first case, where we can spot a D, a string which starts with D. Okay, so here we go, and this is the logic which we have to execute. This logic. So here there is one more if statement. If wait, we need to be sure about that. Yeah, if I is I plus 1 is less than n, right? This has to be checked, right? And hmm, pattern I plus 1 is equal to I equal to D for these things. So this is the flow of D string, right? And then we have this else here where we will just do the incremental stuff, increase, right? So in this case, we will just do this. In num, I will append this num dot pushback dash. I hope this is the correct syntax. Um, Let me just check it. Num char C plus plus. Right, so we need to. This will be ideally T plus one. Right, but I need to convert it to some character, right? Okay, so I can just do this. Um, I can have the ASCII value correct. Do that. Yeah, I can do this. See, I can do this. There is a syntax called char where I can place the ASCII value, which will be typically it would be like we are starting with 1. I can keep it 0, right? 0 plus whatever we have as a number over here, which is basically the p plus 1. Makes sense, right? Then we have to increment p. Nice. And then in this else statement, this particular flow and this particular flow is of t strings, which I have already discussed here. Let me show you. It is this very much this good flow. All right, let's go ahead and code it up. So we know that here in this case, we are spotting like a series of t's. So I'll make a temporary variable called t, which will start with I plus 1, and while this t is less than n, right? We need to check if pattern of t is equal to d, We need to keep going, keep going, keep going. T plus plus. Else we have to break, right? This is a pretty much logic. And let's say what we know that I plus 1 is characterized, this particular I plus 1 is a D because we already have this. And let's say the finality which comes out of this, so this was processing this one, so let's say it was third index, so clearly this was a D, so it will be changed to 4, and let's say 4 is the last one. In that case we know that fourth one is not a D. So in that case, what I said over there was a D count. It would be just the current T value, okay, minus I plus 1. This is the count of the D's we have, right? And now here comes the time to incorporate the current I and do this formality, not the formality, basically do this. Let me just go up here. Here you see we have to fill this particular index with a p plus I plus n, and then we have to progressively go down and down to the to the number of things we have, like number of characters we have, right? Okay, so we can go like this. First thing first, we do this num dot push back, uh, right? This will be a char. So guys, in C++, you can treat strings as vectors, which is very much comfortable when you work with many scenarios, right? So here we have this, and here we will do this kind of thing here. So this has to be incremented by, you see here, we have written p plus 1 plus n, right? P plus 1 for the next one, right? We have to go by d count. D count is the number of D's we have, so we have to go like this, and then we go down and down for the other characters, right? So this is the case. I hope I'm making myself clear, right? And then we have this thing here, which is go ahead with this one, like this, while D count minus minus, we need to do these things. Go ahead, right? So here I have to make some adjustments. I hope I'm doing it well. Mm, I need to check. I'm not sure whether I need to do a minus one over here or not. Because this kind of operators I forgot how they work. But I'm sure about this loop that it will execute decount number of times. Right. Okay, now let's code this one. This is basically this thing without any I in the thing. Okay. So here in this case, I'll copy this particular flow only, like I'll modify it then. So here in this case, what we need to do is to just fix the syntax. Um, no, I just want to format. Okay, yeah. So here we go. So this will be I only because it is a D only, right? Correct. Here I have to do P minus I, correct? Here we don't need to do this, right? We're good, I guess. It has to be 3, 2, 1. So it has to be P plus D count. I think that's what we have written here. We are going with P plus D count p plus decount minus 1 like that. Right, and at the end we can just run this now. Yeah, I think I'm done with the code. Let's run to see if it has any kind of bug or not. Okay, so first thing first, we are getting this weird string over here. Okay, I think we need to be sure about this. Yeah, one thing I forgot to do to update this I when we get into these loops, right? So the length of this loop was decount. I have to do it at this particular step because I want to use, it's fine, I can use t. I can assign this I to t. It's fine, I guess. Right. One more thing which I'm missing is the updating p, right? The p has to be updated with something. P equals to, ideally it has to be, um, p has to be updated, right? Here also we need to do I equals to p, and basically what I can do is can update this p, so how to update this p. This was the last character we spot here, and this is the highest character which we see over here. This will be the ideal p, right? But we lose decount at this step. We need to cache this up. I mean, we need to store this up in some variable. Like, let's get temp. Instead temp is this. Um, this is an integer. Okay, let me just modify myself. I call this temp. So temp is this, correct? Yeah. It's good. So p is equal to temp now. Makes sense. In this case, we have to update p, which is equal to. We have used up. So it will be the first one, which is right here. Also, we need to do this. It is the temp equals to. It would be p plus t count. I'll just use this. I think we are good. I think so. Let me just run it to see if there are errors or bugs. Right, so finally we are getting this kind of string 1243654. 1 2 is happening correctly. This is 4 3 is happening correct. Okay. The entire just as wrong. This is 1. If I spotted I, if I spot an I, it should make 1 2, not 1. It's fine that, okay, here in this case, now, like, we have to do two things, man. But I'm capturing these strings properly, right? So basically this id has been executed well, but these two i's are not. So when I spot I for the first time, it should be 1, 2. So it should be 1, 2. Then if I get another I, it should be between 2 and 3. Okay. So here it accounts for pushing back this. I can do this. I have to do this only for the first time. Let me tell you. I then I have to do this for sure. Otherwise, anyway, discussed. It is a very complex logic. I can cut the code down later on, but this is what I feel at the moment. Increase from what P earlier was. Oh, sorry, यहाँ पे it should be 1 only because P has already been incremented, right? Okay, so far we are good. I has been sorted with 1, 2. Sorry, this first I has been sorted with 1, 2. Next I has been sorted with 1, 2, 3. Next ID has been taken care of as 5, 4. Then we have one more IDDD which has been taken care as 7, 6, 5. So I think we are missing out something. 7, 6, 5 is good, but it should start with. So yeah, one more thing which we missed over here. D count is this, but we need to go till, you know that? We need to go till the very end, because here also we have to increase this D count by 1, right? Here also. There's a big limit that n. This is not easy problem, and this has very much complications attached with it. Let me just try to run this particular flow. Right, right. Let me just think about it. Clear way. D count is the number of Ds, right? So if there's one D, what it should ideally mean, and there is an I in front of it. So here in this case there is no I in front of it. So if there is one D, it means that I have to go with two numbers, right? And it has to be twos and ones, right? So this particular thing has to be increased with 1. What is this temp now? So it should incorporate, the count is increased, right? Temp is what is the maximum value, which is P was let's say 0. it would be decount 20, right? This is fine. So decount to increase, we increase decount here, and temp is also mm, temp is cool, I guess, because we have to here we need to think, yeah. So let's say this number of D's are there. Let's say it's only one D over there, but we know that there is an I as well. So what we need to do here is we need to, what if the first string response is an ID? If we get an I, right, so that is a separate case, all in all, like this one. Let me just take this step out of here, add it over here only. If that if I is equal to 0, and that pattern of I is equal to I, then do this. Okay, do this, right? Do this basically, correct? Right. This will be else if now. So this incorporates the very first thing, right? The first one. Now if we spot an ID, right? Now if I spot an ID after this, which means that I have to add an increasing relationship. It has to be an increasing relationship, so we have added this guy over here. It is an increasing relation. And then we have for each D we have go like this. Makes sense. Then P has been updated with temp. Right, because we have used it. Correct. This is like very long code, man. Right, this is sorted. This particular case is handled differently. I is for 1 and 2, I is for 2 and 3, and then I is for 3 and 6. But for that purpose, we have ID, which has been used up as 6, 5. I is for 1, 2, I is for 2, 3, then there's I. So if I'm saying an ID over there, it should be an I, it should be incorporating 5 and 4. This particular thing will incorporate 5, 4, right? 5 and 4. And then IDDD is handling like 4 characters. It's handling 4 characters only. This ID should handle only 2 characters. Right. This will handle only 4 characters. Makes sense. So we do not need to do this because that is a one-time step. I think now I think we are done with the logic. Sorry guys. So I think the problem is somewhere else now. Yeah, because 5-4 is worked. 5-4 has worked as expected. Okay, I think to better debug this, I can do one thing over here. Okay, so it was 1 2 for the first one. For the second one, it was 1 2 3. Right, it was just an I, right? Then we have 5 4. We have 5 4. Correct, we have 5 4. For the next ITs, right? We have the 5 4 here. Correct. And then next, we did not move ahead. For the next, we are getting the direct response. For 5 4, it was good. For the next, we got it was actually IDTTT. So it should append 1 2 3 4 characters, but it appended. It appended only 3. And उसमें भी गलत. So this particular thing is messed up. So if this is IDTTT like this, then in that case we have to estimate D counts, which is correct. Like the D count is correct, right? T is from where we have progressed. We started with I plus 1, which is D. Right, which is a D, and then in this logic where we spot a break, it is an I, let's say it is an I. So do we have incremented T? We incremented T here. It was an I. So we need to break. So this particular T is either end of the string, which is N, or it is the spot where we get an I. So I think this is correct. D count is correct. Check. I need to check what exact values I'm getting here. And then the P is a different issue. What? Okay, I got this. It is handled here, which is not good. It means that I'm not assigning this correctly. I is equal to T because you spot an I over there, you let it handle, right? I is equal to T, it's a good thing to do. Good. Pattern I is T now, and that is probably T has not been distorted. Let's see what I we are assigning here. Okay guys, so I'm like attempting this after 3 months, so it's quite difficult for me to do this. Here we go, here we go, here we got we got I is 4. 0 1 2 3 4. 0 1 2 3 4, right? 4 is here. This is good, yeah, this is good. Yeah, we had to be here only, right? And this should get into this particular stuff, right? This particular stuff here, but it has not. Otherwise we could have seen I over there. So I plus 1 is less than n. 4 plus 1 5 is less than n, which is the pattern size. Right, that's the pattern size, and it is equal to d. D means this is d, this is d. Correct, this is d. 5, pattern 5 is d, is a d. So this is t is 5 now. We go all the way up to this last one. Right, it should fall here only, man. So it is giving me the num. That's correct. Give me I as well. Okay, so I is 5. Okay, my bad, guys. I'm handling all of the increments and decrements myself. So, so I will be incremented by the for loop as well. This has to be done. And here also, this has to be done. I just forgot, like, right? I forgot that. Yeah, I'll see that. There's no problem. I literally forgot that this for loop is also handling that. For this case, it should be, ideally, it should be that. Just remove these comments first. There's one more comment which I added, I guess. Yeah, wait. Okay, that has been removed. Okay, so here I need to make some changes because this is an I. Decount is this, P is actually 0, and now decount is basically P minus I. I was 0, so T comes out to be 3. This is 0. Yeah, this is I. It was 0 initially. Here we go to 1. We go to 2. 0, 1, 2. Right? It will go till 2, and then it will probably be 3, and then we have 3 minus 0. Correct. Then we did this p plus 3. Correct. P plus 3 is done. And what next? Expected is this. Right. I get it. I get it. Yeah, they expect one more in this case. Because, yeah, the first D relation will be defined between. Yeah, sorry guys, I got that whole thing wrong. Where I forgot to incorporate the size of the string, because when we spot a single I, it will account for 2 characters in num string, which has to be 2 only, right? So here in this case, I'm just handling 3 characters. We have to handle 4. So how can we go about that? We can just go about that by increasing this decount to by increasing this decount to incorporate one more guy. And we'll start with yeah, I get it. Okay, so we have to actually put these many characters. Right, so here it was 3. So here it should be 3. Yeah, I was hoping this is some issue here. Let me just. The decount is actually 4 because it has been pushed 4 times. P plus decount is actually 4, right? Because P is 0. Then 0 plus 4. 0 plus 4 is 3, right? But how? 0 plus 1 means 1. 0 plus 2 means 2. Let me just check. This is 4, correct. Temp is 4. Decount is 4 for sure. 0 plus 4. Okay, I need to add a 1 over there. Yeah, I'm sure about this because decount has been decremented. Correct. I personally myself want to have another test case which will have a couple of IDs like this to see if it passes over there or not. Correct, it passes. Now I'm able to go and submit this code. I'll, I'd like to do it very quickly because I don't have much time. Okay, there's some issue here. Okay, let me just check. 1, 2, 4, 3. This has been there. Yeah, I get it. I get it. Where could exactly this come from? So the first thing is first here. It has been handled within 1 and 2. Which is great. To be honest, it is great, but it has not to be 1 and 2s. The same issue which has been pointed out earlier. Okay, I have something here. I know how to fix this. Right, how to fix this? I know that. Wait. Let me just increase the decount if it is that. I can do that. If I is 0, I is equal to 0, decount. Decount should be, that just simply means that, no. If it's an then for ID, then for that particular purpose, it should be 1 and ID. Let's say it's ID, it's just ID. In that case, what would be the answer? ID means simply 1, 3, 2. 1, 3, 2. Right? 1, 3, 2. So decount is actually 2. Right? Decount has increased. Right. This is the thing, correct? And we go this, do this, we go this, we do this, right? And here in this case, again, we need to check if I is 0. In that case, we need to do this, which is basically copying this and pasting it, and then do the stuff p++, format this, run this. Correct. And then there we go. It has incorporated it in a good way, but the thing is that these two things don't match at all. Basically, the thing is that we have to start. If it's a 0, ideally you should do that. Right? You have to append another guy. Okay, so I got it. I guess maybe I got it. I don't have to disturb this. I'll just do this and I'll do this. Sorry guys, I know it has been very much confusing for you all, but I just want to solve this quickly so that we don't get in loops, right? So this is fine. In this case, what we have done is we have appended this guy. What if there is only one I that will be taken care of? What if there is only one D that will be taken care of? Because this particular case is possible only if we have this will be possible with the zeroth spot. Like the D will appear at the beginning. In that case, this will work. Okay, I guess we are good to go here. I'll submit this, man. Submit this. I hope we are not getting any wrong answers. Great. To be honest, this code is very much different from what we planned, and this happens. Ideally, in these cases, we need to go back to that particular logic and fix it up. But guys, I think I didn't have that time. But from the next streams, I'll try to solve it in a very organized manner because that is very, very important. Okay, so this is cool. I can work out through the logic. So basically, if we spot an I, there are two cases. If we spot an I, or if we spot a D. So this particular thing is a D string at the first place, and this will appear only at the beginning. That is quite sure, because all the D strings later on will be captured in this one. It will have an I in front of it. If it has no I, it means it is the first particular case. So which is handled very well. How it is handled very well, because you guys know, like, we have earlier, what I misinterpreted was that the pattern size and the num size will always be 1 units greater than the pattern size, right? So this particular loop will incorporate that, and for that I'm adding decount. I'm increasing decount to incorporate one more guy, right? If there's one D, we will have to insert two characters. Makes sense, right? And now come to this one. Here in this case, it might be the case. So you guys know that we need to add one more guy, like one more character to make it increased by 1 unit, right? So I am doing that at the very first place. When I is equals to 0, I casually like enter this character, and then I insert as many as i's as many as decounts, because once I increased it by 1 unit, so this is an extra step which I have put over here, which I'm doing it at I equals to 0 step here and here. Basically, this is incorporating the thing that the the unit has been increased, the length unit has been increased. Now you can just go following the particular what we said, following the particular slope, like IEDs. I means go up, D means go down. And then this is the simple logic which we have. Yeah, so that is it for today, guys. It was very much fun solving this problem, and we will meet tomorrow, probably at the same time. I think no one is watching this stream at the moment. This is the simple logic which we have. Yeah, so that is it for today, guys. It was very much fun solving this problem, and we will meet. Okay, cool. Let's meet tomorrow. Bye.